Backstage. I'm Romain Guy from the Android Toolkit team.
I am Tor Norby from Android Studio.
I'm Chad Haas from the graphics team.
I am Esteban from the Android Studio team.
Connected.
Ooh, I like the odds today. 3 Studio, 2 Framework. That means we're going to have a pretty exciting topic, I think. And it's pretty timely. It's live edits, which we just sort of took the wraps off of at Google I.O. this week as we're recording this. So yeah, live edit. What is live edit?
You can think of it as a new way to develop Android application. To me, I see it as two different ways to look at it. First, it's a tool that allows rapid updates to your Android application.
In 150 meters, turn left onto Hiriri Avenue. Take the next left onto Hiriri Avenue, then turn right onto Victoria Avenue.
Meaning that as you type and as your code change, it actually reflects on the device where that's kind of like the first thing. And the second point is it does what we call function decomposition. What it
Take the next right onto Victoria Avenue.
means is as you change your code and your method within your Android application, we use Compose and we leverage this ability to recompose what is necessary in the account.
In 600 meters at the roundabout, take the first exit onto Shore Road.
Active programming language kind of paradigm. You can think that you are actually listening to all your data stream as well as your source code. So as your source code change, your application also drop using Compose. And I think it's going to be a really cool way to look at problem, and I'm hoping the users will have kind of like a way to program Android application without waiting for building and just really immersing their application.
Is it fair to call this hot reload for Compose then?
I wouldn't say that. It's unavoidable that people would compare this, but I would think this is, off of it. It's somewhat parallel, somewhat over, it's kind of at an angle. It's slightly different.
I think it's important for us to figure out exactly where it fits, and then we're going to dig into how it works. So there's hot reload, there's instant run, there's applied changes. Can you maybe try to partition the world a bit so we can sort of see where live edit fits?
I can answer that. We work on applied changes too, and on instant run. Through all of them. Always what we're trying to solve is the iterative development problem, right? That a developer needs to spend time waiting for the build system, waiting for the application to install. Each iteration of solution to this problem attacked a different problem, and this one is two different things for me. One is it skips the build system, which none of the other iterations were able to do. That is a huge difference. And the other one is because it has runtime support, the rendering part of it is supported by the framework, as opposed to the other ones that just attempted to use what it was there. So those are the two major differentiation points with the other ones, which is a huge advantage for us.
In 300 meters, at the roundabout, continue straight onto Air Street.
As the developers of the tools to have the support of the framework, and we get speeds that were impossible to achieve before. Like this is sub-second updates for every change.
It's like a lot less than a second, I would say. Sub-second sounds like 0.9 from a marketing perspective, right? How many milliseconds are we looking at for a typical change?
When we designed the whole pipeline, we were aiming to have each change to be done under 250.
In 600 meters, turn left onto Parnell Road, signs for Newmarket.
We're trying to get it to kind of feel instantaneous while not kind of drain on people's energy process or battery as well. It's smart enough that back off when it's really busy. Let's say if you're refactoring your code or waiting for another complete to finish, we'll back off until we see the editor is being free. And then we'll try to attempt this and try to refresh this with another 250 milliseconds.
So maybe with what Alan said, we can call it instantaneous run then? It's just a suggestion.
Turn left onto Parnell Road, signs for Newmarket.
So I'm really curious. I know some of the problems that were there for instant run as well as applied changes in terms of what you could do that could be pushed across, and then some of the problems that resulted in it, not working this time, and therefore you need to do the whole thing over, and also taking a while longer. And maybe this is partially in your answer, Esteban, and I just don't understand the details well enough right now. I do wonder, what's the magic that we did this time that makes it A, faster, and B, what was the original goal? Like, get the thing there as fast as possible so we can just keep going.
There's two differences, and I let Alan talk about the part of how it actually works, but the main problem with Instant Run was that it wasn't a critical path, so it was attached to the same flow you use every day to code. So you click run, and you didn't have any other options. So when it didn't fulfill your expectations, it would be problematic because it was in the middle of your way. Apply Changes solved that problem by being a separate tool, but it still suffered from the same build system restrictions that Instant Run did. Then with this one, we took it one step further by removing that and explain how we did that magic.
I think another core difference for Instant Run, like you said, it tries to do a lot of things automatically. Where Apply Changes, we are really restrictive. We do a lot of detection. When we write out a lot of error code, we have 40 to 50 errors. But we're going to back off because we're not sure we'll be doing the right thing. So when people try Apply Changes, certain times they think it doesn't work because it tells you an error that you could not fix. That kind of compounds a little with Kotlin, because Kotlin itself also generates a lot of code and it increases your probability. Like, if there's a lot of code, your probability of running into an error is a lot higher. With LiveEdit, the focus is on Compose and obviously Kotlin, right? So a lot of that is alleviated by integrating LiveEdit right into Kotlin, using Kotlin components to ensure correctness and also performance.
You said that it's limited to Compose. What are the other restrictions of the changes you're allowed to make?
There are a lot of fundamental restrictions. There's also restrictions that will currently support. So, for example, right now you're not allowed to add functions yet. Much like when Apply Changes were first introduced, we didn't let people add function until Apply Changes time. We called it Apply Changes 2.0. There's no official announcement for the new version, but certain versions of Apply Changes would let you add function. We call that structural redefinition because we define the class layout of the VM.
So basically, you're allowed to change the inside of a method, is that correct?
That is correct. That is what we think developers, especially UI developers, will be spending a lot of time on it, just changing the body of the functions.
So what you're saying is developers should just write longer and longer functions so that they can take advantage of LiveEdit?
No, I don't. I don't.
Yes, but then you should extract methods. You can extract functions that clean up your code. Like, it may be a good idea for just iterations.
But then when you extract a method, you are adding a method, right? Which is the thing that is not yet allowed. But you did use the word yet, which is hopeful.
Like I said, I think there's two ways to people write program. Either they write out all the function and they get a structural layout, what they want to do, and then they start writing the body. And certain people get the flow going. I would write like a 200-line function, and then that's where my thoughts are. I'm not thinking about dividing the code yet. I'm thinking about solving the problem first, and then I will vector out. So that's kind of the workflow we encourage. You use LiveEdit as much as you can until you can no longer use it, and you just press run and continue to do it again. Or you set up all your functions and structure, ahead of time, and then you use LiveEdit to fill in the body.
I was asking before, sort of, how does this work when we had so many problems with the previous systems or performance or robustness or whatever? And it seems like limiting to Compose means, you're not trying to solve the world here, but I wonder specifically, is it also advantageous to not be dealing with XML assets and having to precompile that? Like, with that one of the areas of failure, or at least difficulty, in the previous systems, whereas now it's just code. We're just recompiling this thing in the Kotlin compiler program.
At least I know for Instant Run, resources were a huge problem.
I think the not having XML is greater than that. You don't break the thought process. Your chain of thought is no longer jumping between XML and Kotlin and Compose. So I think the focus on the code actually really helped making LiveEdit pretty useful.
Another way I look at LiveEdit that I really like is when you're editing code and you click run, you see the results on the device, and then you keep editing your code and then you click run. That's kind of the traditional flow. This one takes you further, but you can still keep your flow. So you're editing, you click run, you see it, you keep editing. Initially, all the changes you're making, you're going to see them on the device because they're in a method, until you get to a point that maybe you edited too much. You have to click run. So in a way, this is extending the life of your editing without getting in the way.
You click run to push it down there, or is it automatically doing it in the background, like pushing your changes as you go?
It's automatic in the background. While you're typing, it pushes everything.
So how does it know that you're not, injecting bugs at the time? Like, how does it know that this is a good time for us to actually run the compiler and do the thing, and you're not in the middle of doing something that's just syntactically broken?
That is a good question, Chip.
That is an excellent question. I think for this current version, we don't have like a good way to do this. For the stable release, we're gonna have ability for the users to control this. I think that's gonna be really important. At some point, you want to kind of pause this. For example, if you're making a network call to users, having fun doing on a device, actually recompose the whole application because there's no way we will know if a calling function is actually creating any cycle.
And so when you recompose the whole app, that means that the app is flickering or something, right? And that is the part that you can avoid if you can attribute it to a particular composable. Is that correct?
That is true.
So that means that if I have a utility function, for instance, say big color, and I call that composable, then modifying just the utility function will trigger a change on the screen. Maybe it will be a heavier change, but at least I will still get slightly less.
Yes, that is true.
But pushing the changes to the device, what does that mean? What do we actually do? Shit.
When we started writing kind of packages, basically we wrote a pipeline we used to install application, and then we started developing this pipeline to do more. So there was a pipeline.
So I just want to interrupt you because I think that there's something that not many listeners know. Like with apply changes, there was a lot of work that the team has done to optimize the pipeline in general. That was beneficial not just for instant run / apply changes, right? But I remember like seeing the APIs got a lot faster, stuff like that. So I just want to make sure we highlight there were benefits for everybody.
Is it worth stepping back and just saying, this is what we did in instant run, this is what we did in apply changes, like just to understand the evolution of these things?
If we go back in time to where we started, and when I first worked for Esteban, that was my first task as apply changes.
When we did apply changes, it was essentially bringing the platform support that we would have needed to build Instant Run. The first step was changing the build system to introduce hooks so that changes could be applied. Then we worked with the platform teams and the runtime teams to include that in the framework itself so that we could build a different way of applying, essentially doing hot swap on the Android RVM.
Does this mean like there was class loader functionality so we could load this thing that was dynamically injected?
The Art runtime supported hot swapping natively. That was one of the foundations for apply changes, together with, like Roman was saying, we improved the time which it took to build APKs, which are still in use today. We don't install every time you click run. We only copy the necessary changes next to your APK. So if you change code, forget about live edit. When you click run today, in the stable version of Android Studio, and you only change code, we do not reinstall your APK. We only copy the new code, the new decks alongside it, and restart the app. That saves tons of time. So all of that pipeline was the foundation for us to build something like live edit. And then you can explain the next step in the pipeline.
Follow this last thing that we requested Andrew's Android runtime to give us the capability to do these kind of things. It was not just instant run and apply changes, it was for portfolios. It opens the door to a lot of things. As we use it more and more, and kind of our eyes widen up, hey, we have this really cool, runtime. We could do a little bit more, and that kind of eventually leads us to live edit, which we use some of these ability to update classes, but mixing a little magic, so we can do it kind of live.
To be clear, these capabilities we introduced for apply changes, that was a while ago. So live edit does not require Android T or anything like that, right? It is compatible with recent versions of Android.
Yes, that's correct. I believe it's a PI 30. I was the lowest that we were able to support live edit.
Getting back to how it works, so apply changes, from that we went to live edit. And now we're still pushing something from the editor. You're typing in the editor, and then we are using the communication that we had for apply changes. And what happens next?
We missed this step. There was actually live edits of the tool, and I think that is kind of like the baby step that we took. From apply changes, we know that we can, at a reasonable speed, change the way the application executes. What if we insert hooks into it, and then we can update literals? And that's basically live edit of literals. Is we update the running application to accept new literals, different literal ID, and we use compose to recompose anytime that we can. Instead of finding that literal, we just evaluate the program. But the first time we do a swap, we actually change the primitive value to an observable, and then we change that, and the application observes that observable as well.
One small funny thing is that when we introduced live editing of literals last year, we were very deliberate in that we did not capitalize live editing of literals because we knew this was not going to be the final feature. Like live edit was already being researched, right? So like this is the first stepping stone. So let's not give it an identity of its own. Yeah, live literals, but live edit was really the goal. And here we are.
I think it's a funny story to Finland. When I was working on live, and it was the drawing tools, I was asking them one-on-one, can we actually do more than and my reaction is not like, I don't really think so, and then he just keep
there's a whole team behind this, and you've all done a great job.
So what does live engine, how does it work?
Falling back, when I was saying that life is always going to change the primitive of the function to the numbers, just think about it as now the whole it's from observing a functionality that can change. And on the editor, as you put it, we're going to use the common compile to compile a, I would say, a class file intermediate representation of the class file. Once we have that, we're going to send it over to the device. The device now is observing any changes to that body. Once the application notices that something is changing, it will start to interpret this intermediate representation. So
I get too interested in this. So the first one is instead of using kind of compilers, are we able to test just function or anything? And you can still bigger scope that test it's entire.
Initially, that was the plan. That was the initial just every single solution is just to compile the functionality using the new kind of code backend that ability for us and engines and we can do the ability to just compile this functionality is what you can. But unfortunately, the backend isn't ready for us to do just that. So we're just decompiling the file level. So it's unavoidable that if no non-trivial file has 10 or 20 functions to it, usually that's the experience. But when you start to have a KT file that has 50 functions, you always start thinking the files that would get us an overshoot. It's not huge, but it's nevertheless once the whole function basis.
It's something to highlight about Diabetic. We said at the beginning that we're skipping the build system. The way we can do that is by leveraging the IDE's internal compiler. So when you're editing, of course, it highlights everything. The IDE knows what you're doing. So we're using that. That saves time. And it compiles to class, and we send class 5 to literally class micro to the device. But it has its limitations because we're not using the build system. If you had some plugins in the build system, so something esoteric that it does to your file, the IDE might not be able to reproduce that. So it's kind of pros and cons, but it gives you amazing scale.
Yeah, but what's interesting is that it seems like theory is going to be different from stuff. Just function.
I was thinking, you're saying it gets slow if you have a really large common file. You know what else gets really slow if you have a large common file? The editor, which we know, right? Like Kotlin is still struggling with performance issues. It's why we're working on a new front end on these things, right? So it's probably a good idea to bring down your code in line I think it was.
What I'm hearing about the processor, the result on the device then is that we have not an intermediate representation, but a different representation of our application that's produced in Live Edit, where we're sending to these little pieces that are then magically becoming observable. And this is not the way that your app would be built, right? So this is like a during development time thing that has this kind of layer of overhead so that we can have this dynamically injectable and observable framework. Whereas when you build it all together, we don't need those pieces there.
That's very true. There's nothing you can change from Live Edit to Reddit. We're working on anything that is exactly the correct Reddit. There's no added magic to it. So once you compile to a development to release build, like all these will just go in as a code left over once.
Not even more than that. Put it this way, we use apply changes to change the first method to support patches that they later get sent to Diabetic. So your app is completely optimal as a developable app is, and then we touch the method that you're touching the first time so that it can receive updates later first.
That is the essence of the build system independency, right? Is that the APK is the same APK you want to build and deploy it into the Play Store. Right? From this talking about you're doing live injecting of something using magic. And that is how you're able to then go and say, okay, first time we change something, we're going to now go in and add some extra stuff.
Yeah, like Alan, earlier you said something about interpreting the compile to build on APIs. So at first I'm like, oh, this step and part, do I need to learn? But then this step class, text, right? So what's going on here exactly? What gets interpreted and how?
In order to kind of hotspot index file, the normal Android SQL format, there is a little bit of overhead that they not want to depends on the layer of the index file. And if we're uploading every time, it takes a long time for it to be adjusted to the new execution format. Also, on the host side, if we're compiling to index, it means we're doing one extra step. So we kind of find it intermediate where we're going to interpret kind of the class extension. It's not exactly class file, it's not a value class file because we don't need a lot of stuff for the class file. It's a trade-off between two. That's kind of how it's
So the Kotlin compiler spits out class files normally. And so instead of having to do the extra step to go from then class to dex, and then from sending dex to arc, and then whatever arc wants to do with the dex file, which is some extra optimization, you're just sending some bits that you can interpret quickly that are bytecode-like.
Yeah, by doing that, we can basically instantaneously swap the method. This performance is not too great because that's what one is going to do. The benefit is just instantaneous to do so. That's important for us to keep our code to the 250 minutes.
I was going to get to performance but a little later, but just so that I understand. So we have a interpreter of another
interpretation of a virtual machine. In a virtual machine, there's actually more than just tooling code. There's garbage collection, there's class hierarchy, class layout. All of those are still depending on what tools. If you think about it this way, you have your running application. We recently take out a little sandbox for that file you just changed, and we interpret the code whenever you call that function. Everything else, invoking allocations and object hierarchy, all those things are still done by the virtual code.
Let me guess, that you guys need to prepare a more Java, which is something to do right?
Yes, interpreter.
Because what happens is you can totally see how you get this by code and you're interpreting it, and then you're calling something. But now, like, it's out of your hands. And Arc is calling. And Arc, they've been calling some method that you have changed. Right? How does that work? That was originally Dex code. Are you going in then and making sure that it's going to fall back into your interpreter?
That's the funny thing. It's giving that's what the interface we call to update the module. You actually update the class partially with line changes. You update the class so it points to the interpreter. But from the VM's point of view, what it sees is there is this class name, there exists these methods, and I'm going to call them other classes in the information. And that's kind of the beauty of it, that outside of this little sandbox, all your performance, all your application is actually going to change.
And you did an applied change where the method is now your interpreter.
Just basically.
I'm still missing a detail here, and maybe I just missed it when you said it, but we're interpreting to what exactly? So you're passing down something else that's not class file, not text. We have our own interpreter that is turning it from those operations into...
It's a subset of a class file behavior. So it's not a fully valid class file instruction, it's the class file.
Right, but then an interpreter has two parts to it. One is the stuff that it's interpreting, which is what you're talking about now, and the other is what's it turning it into?
Right. The input output will be execution, will be instruction to one, right? Okay. If there's a variable, then the interpret method wants to create that variable for you. And if it needs to call a function on that variable, you just get one to invoke that function with that variable you just created. So just that little sandbox we have for control.
Okay, so we end up executing Dex instructions on the other side of this interpretation.
Yes.
Not Dex.
We're invoking Dex instruction. We're interpreting that class instruction. We're executing not Dex, unless the other one is also being like as well.
The experiment to do is when I saw this on Alan Disk, I'm like, okay, there's something here. There's a very simple Java interpreter, eval4j. So that takes a class or a body of a method and it interprets it. I'll compile it with D8 into Dex. I'm running on Art, taking classes as input. That was the test when I'm like, well, this is the thing.
How are we able to not call this like inception? Because I feel like that's a word that always gets used for these things. Like, I think baselines were inception first too. Like, this should have been like code inception or something.
Jen, I think if it helps to think about this, you imagine it's kind of like a scripting language, right? Let's say we define a scripting language, and we have a text file that says print hello. We write a small parser. What you would do is you'd say, well, when I say print, I would call Polyfill reflection or whatever system of how to print hello in Java. Right? And that's my interpreter. Except the other scripting language happens to be a binary format that then I was like, parser. That's my understanding.
That's an interesting observation, right? Like at some point we thought about it's interpreting comments very well. Do we want to interpret? And that's the level. Like we went to the class level, we could have we went to the source level. What if we have only single file source interpreter? That's kind of an idea. We kind of meant it.
Yeah, then you have to pass back the code, which sounds like way more work than interpreting out of bytecode.
What do you think? How we come up with that decision?
Can you talk a bit about how inline functions work? Because they seem like they would maybe throw a monkey wrench into that. Or is there complication here?
Inline function is tricky in that just what I mentioned. We're only compiling a single class, but in the present one, we're just actually compiling a single method into back and forth. If you are referencing another class that needs to be inline, that's getting a little tricky. Initially, we thought, maybe you will just take up a class file from the old directory, kind of pull method body into your current compiler. Let's say you're compiling a.qf and reference another function e.qf. So somehow we need to trigger a compile that has either the source file of e.qf or the output, the e.class.
And just to clarify, this is necessary because the method isn't actually going to be in that class file because the assumption is common C will inline it.
That's something the other user might notice too. If you are referencing a lot of inlineable function, you might notice there might be some performance degradation because we now have to look at more than just class you compile. Although I should say that anybody start using inline. We're working really hard to improve the performance of the cache, what's going on in the cache, function one to make this case more useful. But for now, expect a little bit of delay if you referencing a lot of functions.
Is that true for inline functions in the Compose framework too, or is it more primarily of local inline functions?
Local inline functions. If you have enough functions from the framework, it's entirely fine. There's a lot of things for a lot of inline, so that's fine. If you're referencing a library, that's not an issue. The only issue is that you need to come out with a source file, and that's why you're going to get a lot of bit of performance degradation.
Speaking of performance, we inject into the class methods as a prepare, obviously, which is fine, pretty good. But I imagine that
build than it should be on real device, not emulator. Profiling and live edit seems like they're not really meant to be together.
You can leverage it on the real device, but it's not just
Yeah, this is true.
But don't do what you're saying. Just don't.
It's kind of neat because this works on a real physical device, and in Electric Eel we also have the ability to have the physical device show up as if it were the emulator. So it's very, very seamless to sit there with the editor and to watch your live device in your pocket right there next to the editor as you're making these changes. It's pretty cool.
So to request for performance, put the provider give you warning if you write on 10 sheets, maybe it goes like what happens. Maybe it will.
You could, it just maybe it doesn't seem worth it. I don't know. I haven't tried to do this, right? It seems really like
I would.
okay.
The profilers are actually going to give you a warning if you're on debuggable apps and help you switch directly to a release variant. That's it works.
I know the benchmark libraries do the same thing. They complain if you're trying to actually run a benchmark. That's not just that works.
Yeah, we have a new feature for profilable apps in Studio where we give you sort of reduced fidelity for the things that we're profiling, but they're much more accurate.
We've talked about some of these restrictions online, but if people are trying to try this now, because the Canary is out, right, so people can get their hands on this, it's up and build a list of ships.
Yeah, Electric Eel Canary one.
Please try it out, and please don't be surprised if it breaks due beam.
Well, before we say please try it out, I actually made this mistake because I switched to a newer build and it actually changed how the flags work. So I thought I was actually using live edit, and it seemed to work because of course there's live literals, right? So I was changing the strings like, oh cool, it's working, and I was like, wait, live edit's broken, what's going on? I should talk to Esteban and Owl about this. And I realized, no, I hadn't actually turned it on because this is an opt-in feature. So, it's not enough to get Electric Eel Canary. You want to go to settings, find live edit, and turn it on. Full feature.
I want to go back to Jake's question. So, like, lots of things out there. So, obviously, there's still some polishing issues. One thing I would like to point out is this thing called partial recomposition. It's not fully implemented. There's like a simplified that we use to test. But what it does is, I mentioned earlier that when you do a edit on your function, you're supposed to figure out what needs to be recomposed. That is not technically fully working until you have this flag in this feature turned on. Expect that if you are editing a composable app, it might kind of lose a lot of state when you edit. If you have a navigation controller, it might go back to the original destination.
It's kind of like an activity restart.
Yeah.
In the I/O demos and in Jamal's keynote demo, we had recomposition turned on. That's the feature that's coming.
Yeah, that feature is good.
Is there the concept that, like, if you're sort of in the flow and you're doing a bunch of stuff, that maybe occasionally you just kind of want to reset the state of your application to put it in a happier state and maybe reduce some of your overhead? Like, would somebody want to, every however long, press run, and that's going to then send down a full APK that then starts being injected by live edit all over again? Is that the way it works, or does it stay in this sort of injectable live edit mode until you do a release build? Like, how does it work?
I think it is a good practice to occasionally press run. It's funny, if you think about how live edit works, it captures the whole timeline of your development cycle. It has every single keystroke, and if every keystroke generates an event within your application, those events are going to be there, and those are the state that you could not get into your normal applications. It's both a really powerful tool. We can use it to debug and do a lot of cool stuff with it, but that's something to keep in mind is if you want to see a complete refresh of your application, press run. It's definitely what you want to do.
And speaking of these intermediate states, can you talk a bit about error handling? So let's say I'm making a change. I add a parameter to my method, for example, and it's no longer live editing because it can't. Can I then undo and then I'm back to good state, like I could with apply changes? Or talk more about the error handling and consequences for how this works?
That's a good example, but I think even a better example is, what happens if you are typing out a function and then your function actually expects a optional parameter, for example, and you have not finished typing your arguments to that function, and now we got live edit and it's missing one of the parameter that falls a null pointer exception. Well, that's going to crash your app. That's kind of the more trickier error state that live edit user could potentially get into. For now, we are going to let the application do what it's supposed to do, but on the stable release, we're going to have error handling. And that if we ever detect an exception that occurs during recomposition, we're going to show you an error message on the application on Ender Studio, and then we actually going to use your previous well-known recomposition state. So if you accidentally type a null pointer exception somewhere, we're going to tell you, hey, null pointer exception actually happened on the application. But we're going to not recompose yet and try to fix it. And if you don't want to really fix it all, you just want to continue typing the rest of your code, you can finish typing and press run and everything that we started. Or you can just live fix that, and then we'll continue to recompose for you.
Error handling is a big topic, and we're working on all the aspects of it. Like throwing an exception. If you just write throw some exception, it'll throw constantly. But you can get cases where you write a while loop where you put the variable, and you haven't yet set the variable to break out of the loop. So we push that, then you're in an infinite loop. There's nothing we can do to stop that from happening. But because we have an interpreter, we can think of strategies to exit that as soon as a new patch comes in. So there's a lot of angles to I made a mistake in code and I pushed that. Some of them we can recover, some of them we're going to show a message in the UI, but some of them you wrote correct code that crashes your app. That will be successfully be pushed and crash your app.
We talked about this a little bit earlier, but the states that you can get into, if you really are in the middle of a thing where pushing the code is not the right thing to do, and the developer might know that, is it a different way of using the tool eventually to have a mode you could go into where you don't want it to push, but instead you kind of want to hit a function key because you know the points where it's going to be ready, or you basically like pause that live editing session and then re-enable it when you're ready to go back into that mode?
We're still kind of doing a little bit of research and experiment on how this is going to work. There is going to definitely be a way to either pause the or just toss them this file, or maybe just enable this file. We're not 100% sure yet, so like I said, feedback will be welcome. On top of that, I would like to add that the way you do think about live edit, it's almost like you're writing shell script in the shell, right? You're typing some function and executing it. And whatever left over from the previous line you typed, it's going to be there. So that's something very important to keep in mind, in that you could potentially get into the state where the previous edit triggers an exception. So that's something that hopefully using Jetpack Compose solve a lot of this, because you're supposed to declare your data dependency in a way so that Compose understands it. There is going to be a way to temporarily disable it, and also ultimately this is something that is not really intrusive. You can continue just ignore your live edit application and just press 1, just like what you have been doing so long.
And you wonder if this will affect the way people's workflows. You can, for example, imagine now it's very easy while the app is running, just go and add a logging statement. And it's like immediately applied. Now you can just open up the new logcat and you can sort of see the value. As opposed to like, okay, always starting in a debugger and maybe setting a breakproof. Like maybe printf debugging is going to be kind of nice now that it's so easy to apply.
Yeah,
printf is back, baby.
Definitely. I haven't done a lot of UI programming, but I have to do a lot of testing on Jetpack Compose and its toolkit. And it's just so easy. Like if I don't understand something, I just type this, I'm going to set up a lazy row, lazy column, and see what it looks like. Once I'm done, I'll delete that code and continue doing what I'm doing.
Well, Esteban's also in charge of the debugger, so you have to find a nice balance between the teams here.
喂，
你到哪儿了？
我下高速了已经。
哦，很快了。那你到了给我打电话吧，因为这边车位好像没什么车位，你直接来门口，然后把东西放下，我们去吃东西，可以吗？
行。
好，拜拜。
拜拜。我买了很多带回去的东西啊，小峰总是让我们带回去菜去。
你觉得不需要放冰箱的给我，需要。你觉得需要放冰箱的给我，不需要放冰箱，你放你后备箱里就好了。
好的。
好吗？好，拜拜。
拜拜。
Great things about Compose and Live Edit is that they seem to have been created together, because Live Edit is really good when you can execute your code multiple times. If I apply a patch and I set it again, the nature of our composition is you don't know when it happens, and it happens when it's needed. So that is when Live Edit is great, right? Imagine if you were doing Live Edit of literals to edit a SQL statement that says create table, and as soon as you type the table name, we create all the intermediate tables. It wouldn't work for any backend code, so it's perfect for something like Compose, and we're really excited to see it working.
I do think that the whole discussion about should it be happening when you press a shortcut or should you opt in or out of pause, I think it's interesting, and I suspect this is not a promise. It's just a prediction that we'll probably have an option for this. Studio has quite a few options already, but this seems like people will maybe have different workflows, different ways of working. I have to say that sometimes I feel a bit stressed when it's it's watching me and I'm trying to think and it's doing something, right? And if I can just finish my thought and then apply, I might prefer that. We're going to collect feedback, including from all of you listening, hopefully, for that. What do we not ask? Is there anything else that's sort of interesting technically here, or other limitations that people should be aware of? Or anything else you want to share? Or we actually have a call to action. We just download Electric Camp Clearing 2, probably by the time you hear this. It's additional fixes.
And enable the option that flew by pretty quickly. So whenever somebody says that, I think, I'm not going to try it because I can never remember where those things go.
If you go to the settings, to the experimental page, there's a setting to enable Live Edit. There's also a setting to enable the mirroring screen of physical devices you can use together with this. Please send feedback.
It should work easier. This sounds awesome. We saw the demo internally a couple of months ago, I think, in some meeting, and I was like, I don't do that for works really good.
I mean, a lot of the feedback we got from Compose, is it'll be compared to some other frameworks that are reactive that are not based on static compilation and things like that. Right? So this was a pretty great need, I think, for the success of iterative development. So it's pretty great that it's happening. Thanks.
Thank you for having us.